This is the study guide for Test 4 for Quarter 1 for Algebra A. And so let's take a look at our first problem here. It's asking us to solve an equation with variables on both sides. So the first step I'm going to end up doing is bring the variables to one side of the equal sign. Now it doesn't matter whether you bring them to the left or bring them to the right. You'll still get the same answer either way. So when I do this, I'm left with 3a minus 17 equals 1. So from this point, now I want to bring the constants to the right-hand side. So I'm going to go ahead and add 17 to both sides. So when I do that, I've got now 3a equals 18. One more step here, and that's to divide by 3. So our answer in this case is a equals 6. So taking a look at the next one, it requires some combining of like terms on both sides of the equal sign. That's what I'm going to do first. Now notice the signs are both, well, one's negative, one's positive. So they're opposite signs. So that means I'm going to subtract those two numbers. I'm going to bring down that minus x, bring down the equal sign, and then combine some like terms on the right-hand side. Notice how they're both positive here, so that'll make a positive 8, and I'll bring down that positive 4x. So from this point, it becomes a problem just like we had just done. So this time I'm going to bring the x over to the right-hand side. Again, it doesn't matter which way you bring the x over to which side you bring it to. It's just as long as you bring the constant to the opposite side. So now I've got 3 equals the 8 plus 5x. So now you see I want to move the 8 to the left-hand side. So now I've got the constants on the left, which I'm left with negative 5 there, and the variable on the right. So I have the 5x. So from this point, I'm going to divide by the 5, and that gives me a negative 1 as the value of x. Let's take a look at the next problem. It requires the distributive property to be used. So I'm going to distribute the 6 over the y and the 3. So that makes 6y plus 18. And bring down the equal sign, distribute, and I'm left with a 2y minus 6. So from this point, I'm going to subtract the 18 from all sides. And when I do that, I'm left with a 6y equals 2y minus 24. So now I got to bring the y's to one side, so I'll go ahead and subtract that 2y from both sides. And when I do that, I'm now left with a 4y equals negative 24. So from this point, I'm ready to finish solving by dividing by 4 on both sides. And notice how I divide a 4 into negative 24, and that leaves me with y equals negative 6. And looking at the next problem, this one's a little bit more difficult because we have a constant and then subtracting an expression. So we can always put a 1 in between the minus sign and the parenthesis, and helps you remember that you're going to distribute that negative 1 over that subtraction. So what we have left is this 5 that I'll bring down, minus an n, plus 4. Make sure you have that positive 4 here. That's the common mistake people will make. On the left-hand side, distributing that 3 over that addition, so we have 3n plus 6. So now I'm ready to combine some like terms on the left-hand side. I got a positive 5 and a positive 4, which makes 9. So minus n equals 3n plus 6. So notice that when they are the same sign I'm adding, I'm looking at the signs in front, not the signs behind the term. So now I'm going to go ahead and add that n to both sides. Leaves me with 9 equals 4n plus 6. And so now I'll go ahead and subtract the 6 from all sides, and that leaves me with a 3 equals 4n. So I see that the coefficient is not going to go into the constant. That's okay. The answer is a fraction, and it's reduced. So 3/4 is the value of n. Looking at the next one, this is an absolute value equation. So what we want to do is isolate the absolute value first. So I'll subtract that 2 from all sides. That'll leave me with this 3x inside the absolute value bars equals 6. So now once I've got the absolute value isolated, it's set equal to a number, and it's a positive number, that means there's 2 answers there can be. So I'm going to go ahead and find out those 2 answers of x by setting 6 equal to 6 and negative 6. And So from that point, all I have to do is divide by 3 on all sides, and I get my answer. So negative 2 is one of the values of x, 2 is the other value. So those are the two numbers that go in my solution set. Another way to show the solution. So the next problem, it's already set equal to 0, so I'm going to take that 5x plus 2. I'm going to set it equal to 27, but I'm also going to set it equal to negative 27. So when I go ahead and solve, I'll go ahead and subtract the 2 from all sides. And when I do that, notice how the negative 2 and a negative 27 end up adding to make negative 29 equals 5x. On this side, it equals 25. So from this point, all I'm going to do is divide by 5, and that'll give me my two values of x. So whenever the absolute value is set equal to a positive number, that means there's going to be two possible values, negative 25 fifths, and negative 29 fifths, and 5 in this case. Well, let's take a look at the next problems, next 3 problems. In this case, here we are having to subtract the 1 from all sides, and this is an inequality, so we just have to be careful of the inequality sign. So 2m is greater than, we have 13 in this case. So when I go ahead and do some division, divide by 2, notice that the inequality sign is staying the same direction because I'm dividing by a positive, and I'm left with 13 halves. Now you can write that as m is greater than 6.5 or 6.5 is fine. And if I was to graph this, put 0 here, 6.5 is right over here on the number line. It's an open circle, and the values of m are bigger, so they're going off to the right. This next one, I subtract the 8 from all sides. I'm left with this negative 3y is less than or equal to negative 21. So from that point, I'm going to divide by that negative 3. Now notice that since I'm dividing by a negative, it's going to switch all the values of y. See, y was less than or equal to, but when you divide by a negative, the sign is going to switch. So now it's a positive 7, so the y values are now greater than or equal to that positive 7. So if I was to graph this, 7's off to the right. Closed circle this time because it equals 7 as well as being greater than, so it's going off to the right once more. Next problem, it says a painting company charges $610 plus $21 per hour. So plus 21h. Now I know it's h goes here because whenever they say per hour, that typically tells me that's my variable term. Well, I go ahead and read the question. It says, how long is the job for which both companies will charge the same? How long? They're talking about time here, so they're talking about hours. So that's the unknown. So we don't know that, so that's where my h goes. So another company charges $555 and $26 per hour. Now notice I put the equal sign in there because of that word same. Same means that we're going to set them equal to each other. So now since I've written my equation, I'll go ahead and solve. Subtract that 21h from both sides. And I'm left with a 610 equals 555 plus 5h. And so I go ahead and do some more work there. I subtract that 555 from all sides. And notice that I'm having to borrow a few times. All the way back from the 6 changes to a 5. 11 changes to 10, and now I'm ready to do the subtraction. So I've got 55 equals 5h. So we've got one more step. I'm just going to divide by 5, and we've got our answer. So 11 equals h. And give me some units on that. So it's going to be 11 hours is the amount of time it's going to take until the two companies end up charging the same amount. Well, those are the types of questions you're going to see on this week's test. Good luck.